Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, students, subscribers, and viewers. Here is another problem in calculus. I hope that your thinking skills will develop here, especially on the definition and interpretation of slope of tangent to the curve. And if you want to, those who want to anticipate the solution to these problems, you may do so as a challenge by posting the video. Do not look at the solution, just compare answers later. So use the given graph to estimate the value of each derivative. Then sketch the graph of f prime. So the value of f prime for slope of tangent to the curve would be f prime at -3, 1b f prime at -2, C f prime at -1, D f prime at 0, 1e f prime at 1, 1f f prime at 2, and 1g f prime at 3. And here is the given graph. It's a little bit distorted. However, we can estimate the slope with based on this figure here. The result will not be so affected. So first f prime at 3. So this is x is negative f prime at -3. So this is f of x. So the graph f prime -3 is the slope of the tangent here. So let us estimate it. Definitely the rise is 1. That's a positive slope. And we estimate this as about 2/3. So that is 1 and this is 2/3. So therefore, the slope is positive 1 over 2/3, and that is 3/2 or 1.5. So 1a f prime at -3 is 1.5. Then at -2, it is still positive as shown. So uh, this is about 0.6, and also this one is about 0.6. Do you agree with the estimate? So 0.6 over 0.6, the slope for f prime at -2 is 1. Then next is f prime at -1. So this is the highest point, and I think you will agree that the tangent is horizontal. Therefore, f prime at -1 is 0. Horizontal tangent is 0. The slope is 0. Then 1b here, this is the tangent. So if you agree with the tangent, then rise is 1, 2, 3, 4. Run is 1. And since this is a negative slope, positive 4 over -1, then the slope is -4. So f prime at 0 is -4. Then at 1, this is again the lowest point. So the tangent is horizontal approximately, or it may be accurately. So therefore, f prime at 1 is 0. 1f, f prime at 2. So we estimate again, we draw a tangent, then estimate the slope. So this is about 0.3 or 0.35. That's 0.6. We'll just call this 0.4. Estimate this as 0.4. 0.6, then 1. The slope is positive. So f prime at 2 is 1, positive 1. So f prime at 2 equals positive 1. And finally, at f prime at 3, so the slope of the tangent 1, 2, 3 here. So if you agree with the tangent, this is 1.5, 0.5 and 1, and 1. So 1.5 over 1 is 1.5 or 3 halves. So therefore, f prime at 3 is again 1.5. Then we sketch the graph of f prime. So we will include the slope of the tangent here, which is greater than 1.5. We may call this, although not required, as long as it is higher than 1.5. So this would be the resulting graph of f prime, because when x is negative 4, the tangent line here is estimated to be 1.8. Just an approximation. 1.8, then 1.5 when x is negative 3. F prime, so y equals f prime of x, or simply another function. So f of x for g of x, where g of x equals f prime of x, is 1. Negative 3, 1.5. So that's 1.5 and negative 3. At 2, negative 2, it is 1. So that's why we have 1. At negative 1, we have 0, so 0. At 0, f prime of 0 is negative 4. So 0 comma negative 4. Then f prime of positive 1 is again 0. So that's why you have 1 comma 0 here. F prime of 2 is 1. So that's 1. And x is 2. And finally, at g, f prime of 3 is 1.5 again. And by symmetry, we'll just make the last points, the end points, as on the same level. So 1.8, 1.8. The graph of f prime of x, therefore, will be as shown in the figure. We connect these points with smooth curve as shown. So that's the graph of f prime of x. So that's it for this video.